Okay, we have another one. Solve the equation. This is the case. For now, the first thing for you to note is you note the range. So now the range is given in radians, meaning even our answer should be in radians. I think we saw that when we are covering trig as a topic, how to convert angles from degrees to radians. So what are we going to use here? In most cases, when you start, we have a product of sine, cos, and so on. It implies you may use the idea of factor formula somewhere. That's why here I'm setting this formula because we are going to use it somewhere. And we're also going to use a double angle of sine. Double angle of sine says sine k theta is equal to 2 sine. These angles are halved, as you see, like that, they are halved. So if you have this as k, this one becomes k over 2, then this 2 is always there. So in simple terms, if you have this as a 2, this one is going to be 2 over 2, which is 1, 2 over 2, which is 1. If this is 4, then this one becomes 2 theta, 2 theta. So in simple terms, whenever you have this for the double angle of sine, or is that angle is half the other angle. Then this is how we did the angles in those quadrants. But you need to be careful about the angle you are having, as we are going to see. So now our simple case, you start here, you look at cos theta and cos. By the way, you can just first pause the video and then you try it out and then you compare the answers after. So start here, I have cos theta and inside you have cos theta. So I just take this side. So when I take that side, I'll be adding now sine 2 theta, this side equaling to cos 4 theta, cos 6 theta, then minus, when it goes this side, then cos 4 theta. Of course, you could now see that we are going to factorize out in simple steps in one step, and they do it at once, but let us take our time. So, sine 2 theta here, what I'm going to do, I'm going to factorize out this cos 4 theta into, here remaining with cos 6 theta, then minus cos 2 theta. Okay, now what I'm going to do is that here I have something which is going to require me to use the idea of factor formula. I think it's very similar to this. So if I have this, then I use this idea. So I'm going to apply this to my A, this is my B. So if it's negative and I have cos, this negative, don't forget it always. So I have now sine 2 theta equaling to cos 4 theta into now. We start with r negative 2. We saw how we prove all these things while applying them. Okay, so this is going to be now sine, get this angle plus this angle, then we divide it with the 2. Then still, after doing that, then you still get your sine, and then you subtract those two angles, minus 2 theta, the whole over 2. So that is the case. So after, let us see what happens if we simplify. So this is going to give us sine 2 theta equaling 2 cos 4 theta. You could do them, you can reduce the steps, but anyway, for the purposes of explanations, let me just include my steps, all of them, minus 2. You see, this is going to give us 8 divided by 2, shall be having sine 4 theta. 6 minus 2, that is 4, divided by 2, we have sine 2 theta. Then if you open brackets and you take everything inside, we shall be having now, okay, sine 2 theta be equaling 2, negative 2 sine 4 theta. When I open this and I bring it close, cos 4 theta, then sine 2 theta. Why am I bringing it close? I want to apply this idea here. So, can I try to bring everything inside? And try to bring everything inside. We'll be having sine 2 theta. I think this is going to be common. You can plus 2 sine 4 theta. then cos 4 theta, then sine 2 theta equal to 0. If you see it's common, factorize it out. Here you should remain with, when you factorize this out, here remain with 1, then plus, we remove it here, remain with 2 sine 4 theta, cos 4 theta, which we have seen already, it is already something. When you compare now this and this, I think you see, we have 2 sine cos, so meaning this angle was divided by 2. So meaning this was is the same as 8 over 2. In simple terms, I want to get the k. To get the k, I multiply the angle here by 2. So you see, if you multiply it by 2, you get k. So then the whole of this will be equal to this k. So here, this one here, it's now 8 over 2 in this cos. So it's that this one is 8, this is 4 and this is 4. It means the angle which was used to get these halves, it means it was 8. So now this is going to be sine 2 theta into 1 plus now sine 8 theta equaling to 0. I think you see the idea. So if we expand now this, if it's 8, you are going to get 2. 8 divided by 2, which will be 4. 8 divided by 2, which will be 4 still. Okay, so from there you can see, so either sine 2 theta is 0 or 1 plus sine 8 theta is equal to 0. Now, this method, this ideal, works only if this is a 0. When you have a product of two things, when you are equating them to 0. If this one is something other than 0, it doesn't work. Then you just bring one side and you solve that quadratic equation. It is a quadratic equation. So, whenever you have a product of two things, when they are equal to 0, this means that one of them should be a 0. That's the idea. So, if you have this row as 1, 2, 3, this one can never happen. So, now you first solve this. So, now consider. We consider now sine 2 theta equal to 0. Of course, you know the quadrats where we are going to get a 0. But to start this one, we know the ends. So which quadrats are those? Now that this angle, first of all, is not 2. It's not 2. So what we do? We first multiply it by 2. So you see, we have theta degrees less or equal to 2. Now 2 theta, multiply it by 2. Less or equal to 2 times pi over 4. So that's the idea. The angle here is what we base on. So before this angle should be the same as this angle. Before you get the degrees, that's why now the range I'm going to use is for 2 theta less or equal to pi over 2. Now you see that the angle there is the angle I have there. So this 2 theta here should be the same as that 2 theta there, as you see. Then you can get your angles. So you see, this one will give me 2 theta, sine inverse of 0. Of course, we have 0. But you see, this is the same as pi over 2 is the same as 9. So it's the only thing we are going to get 9 from 0 to 9. Remember, pi over 2 is the same as 90 degrees. So that's why I'm stopping at that. So my theta here is going to be 0 degrees. Then I come to 1. Okay, I said consider. Four. Now 1 plus, now this one. Sine 8 theta equal to 0. I first take this inside. I have sine 8 theta equal to negative 1. The moment you say negative, you indicate which quadrats the sign, where sign is negative. You know that? Those are two quadrats, of course. The third quadrant and then the fourth quadrant. That's where sign is negative, basing on this. Now from there, you look at the range. The range we have is 0, less or equal to theta, less or equal to pi over 4. You look at this angle, they are not the same. So what you do, you first multiply through by 8. Here by 8, here by 8, here by 8. So that this angle, the same as the angle which is there. So by 8 here we have 0, less or equal to 8 theta, less or equal to 8 times pi over 4, which is that we have theta less 8 theta less, when you simplify you get 2 pi. That's that this angle is the same as that angle. That's the first thing you should do. That's the first thing you should do. Now you see that this is 0, okay, the angle is the same. Now you can easily get the angles. So see that this one is the same as from 0 up to 360 degrees. So if it's beyond 360 degrees, we have seen also how to do that in our topic in trig. So this thing is helping you to get the acute angle. So that there the acute cos inverse of 1 is going to be 9. So my theta, 8 theta here is going to be 90 degrees, but this one is in the acute angle. The acute, this acute is always expecting us to get other angles in the other quadrants. So my 8 theta now, these angles are going to be now. And then in the third quadrant and the fourth. So in the third, we get 180 plus the, now this is our acute, or is this theta is acute, plus 90 degrees, comma, and then we get in the, which will be 360, then minus 90 degrees. This is the third, and this is the fourth quadrant. As simple as that. So here, remain with 8 theta equaling 2. So this is going to give us 270 degrees, and the same that is also going to give us 270. So divide through by 2, our theta becomes, so that we go back to our range. You do that, but you only divide through after getting all the angles. You start even here when you subtract, we are getting the same thing. We are getting 270 degrees, which is the same. So from here, then after getting all angles, then you can divide through by 8, that side. So you get 270 divided by 8, we get 33.75 degrees. But now remember, our angle was given in radians, so you also convert this to radians. How do you convert radians? You divide by 180, then introduce the pi. So this will be now, so this will be 0.75 divided by 180, then pi. And so you are very free to stop there, or you can simplify it to, it's going to be the same as 3 over 16 pi. So therefore, our angles are, our theta is going to be 0 degrees, comma, 3 pi over 16. That would be our answer. I think you see here, I never wasted time because when divided by 0, still is not 0. So that would be the range which we shall be having. Now we see this one is between this and this. As simple as that. So that's how we handle that. The idea was, how do we handle when the theta, when the angle here is not the same as the angle in the given range. That's it. I wish you well. Please don't forget to subscribe to the channel and share with friends. See you.